Hey guys, these notes are going to cover evaluating functions and sequences, and we are in Unit 2. Our essential question is, how is the language of math communicated? So this is going to be a two-part video since this lesson is kind of broken into two sections. We're going to first talk about evaluating functions in this video, and then talking about arithmetic and geometric sequences in a different video. So we'll go ahead and start off with some vocabulary. So our first word here is function. So the definition of function that I'm going to use is that for every input, there is at most one output. Now the key word here is keywords are at most. So if I'm putting something into a function, at most I should get out one output. So again, you're putting something into a function, that's the input, and then the most amount you can get out is one output value. And that's saying at most. So you cannot have two, you cannot have three outputs, you can have at most one output. At most also specifies technically that you could have zero outputs because at most means you just cannot have more than one. All right, and then we're going to talk about function notation a little bit. So function notation is kind of how math is communicated. So you want to make sure that we can kind of get our minds wrapped around what that looks like and what it really means, and not to make it as complicated as it actually looks. So I'm going to go ahead and use the parent functions as our example here. So we have three parent functions in algebra. One, a linear parent function, y equals x. We have the quadratic parent function, y equals x squared. And we have the exponential parent function, which is y equals 2 to the power of x. Now, these are all functions that we learned in the first lesson of parent functions. All of these are functions. Now, function notation is basically saying, okay, well now instead of saying y equals x, we're not going to say f of x equals x. And instead of saying y equals x squared, we're going to say f of x equals x squared. And then lastly, instead of saying y equals 2 to the power of x, we're going to say f of x equals 2 to the power of x. So what are we really changing here? We're just stating that our f of x is going to replace the y value that we had before. It means the exact same thing. It's just that instead of saying y, we're going to use f of x. Now you're like, well, why don't you just use y all the time? Well, in future math classes and on your STAR assessment, it's not always going to say y equals. It might say f of x equals. So it's good to be aware of all the different ways you might see it. So that's why we kind of talk about it as well. And then we're also going to talk about evaluating. So the way that I think of evaluating, I'm thinking of I'm going to plug in a number to evaluate for that value and find an answer from that. So we're going to go ahead and use an example for evaluating. So let's say I'm given the function y equals 5x minus 2. I'm given the function y equals 5x minus 2, right? Now, they also give me a value of y equals 3. So I'm given two bits of information here. I'm given a function, and then I'm giving a y value. So evaluating is basically saying, take the information that's given and evaluate for that value. So I'm evaluating for y equals 3. Well, I know that y equals 3. So what could I possibly do with the number 3? Where could I possibly plug that into the function? Well, I know that y equals 3, so I could plug in 3 for my y value. Why wouldn't I plug it in for the x value? Well, because it says y equals 3. It doesn't say x equals 3. So then I have 3 equals 5x minus 2. So I'm plugging it in for my y value. Well, from here I'm going to evaluate the function, and I'm going to solve for x. So this is basically unit 1. We're like, okay, let's get x by itself, solve for x here. First step in solving for x here, if I want to get x by itself, I got to get rid of the 5 and the 2. Now we want to get rid of the 2 first because remember when we're solving equations, we do PEMDAS backwards. When we're doing PEMDAS backwards, we're adding or subtracting before we multiply or divide. In this case, we're going to add 2 to both sides first to get rid of this negative 2. That's going to give us 3 plus 2, which is 5, equals 5x, which is what I still have on the right-hand side here. Now, x is still not by itself, so I want to go ahead and divide that 5 off of that x. I'm dividing because they're connected by multiplication. I want to do the opposite. But anything I do to one side, I got to do to the other. So 5 divided by 5 is going to give us 1, and I have 1 equals x. So I evaluated for the function. I had a y value, and then I evaluated for x. Sometimes we'll be given the x value, and you're going to evaluate for the y value. All right, now I've already kind of said it a few times, but this right here, f of x, is read as f of x. We don't say f parentheses x, we say f of x. So if I was given this, I would read this as h of n, because I read the first letter first, and then I say of, and then I read the second letter. Now what if I don't have two letters? What if I have a letter and a number? So something like this. This will be read as g of 3. So we're not going to say G parentheses 3. We're going to say G of 3. It's less of a mouthful to say. It's also easier to say, and all of us math people understand exactly what you're talking about. All right, and we want to make sure everyone's on the same page, so that's another reason. Let's go ahead now and talk about some more vocabulary, input and output. We kind of talked about this with parent functions yesterday. So when you guys had your parent functions and we talked about graphing them, we had an X and a Y table. I don't know why I switched colors like that. Here we go. I have X and Y values here. And on the X side, I have -2, -1, 0, 1, and 2. And we talk about how these values don't ever really change. We can change them, but that's based on whether we decide to scroll down in our calculator or decide to use different numbers. So these values over here typically stay the same. So our X is going to be our input. So our X values are typically your input values, and really your X is always going to be your input values. Your Y value is what your output values are going to be. So X is what we have, and then the Y's are changing constantly. So based on a parent function, we had either like the same exact thing. The linear parent function, it had the exact same thing as the input. So whatever I put in, I got the same thing out. With quadratic, I would get 4, 1, 0, 1, 4. That would change based on because I used the quadratic function there. And then I had exponential, which gave me 0.25, 0.5, 1, 2, and then 4, right? So the Y values are constantly changing because your output is going to constantly change depending on what you put into your function, what you put into that function machine. Now, two words also I want to use here are the words independent and dependent. Your X values are going to be your independent values because you can't change those. Those are independent on their own, and it's not going to affect the problem. It kind of affects the problem, right? So your independent value or your independent value that you plug in is going to affect it because your output depends on that. So your output, your Y, is dependent on your X values. So for example, these values constantly change based on your function because you plugged in these guys over here. So these guys didn't technically change your function. Your function would change and then your function would have different output values. So you can also think about input is independent. So anytime you're given an independent item or independent value, that's going to be your X value. If something is dependent, that's always going to be your Y value. And then the last two words I want to mention are two words that I mentioned on the first date with parent functions. One is always associated with X, and the other one is always associated with Y. The words that's always associated with X is going to be domain. If I'm asked to find the domain or I'm given a domain, we're talking about X values here. So always remember that domain is associated with your X values. And then range is always associated with Y values. So if I'm asked to find the Y values or I'm asked to find the range, it's the same thing. Or if I'm asked to look at the range, I'm asked to look at the Y values. All right, moving on to the next page of the notes. How would we evaluate the following equation if X equals 6? So we kind of already talked about evaluating on the front page when I kind of gave you an example of what evaluating is like. So again, here we are given some bit of information. We're given X equals 6, and then we're given a function down here, Y equals 3X plus 1. Now, just to kind of remind you from day one, this would be considered a linear function. If I graph this in Desmos or if I graph this in my graphing calculator, I'm going to get a straight line here. Why do I have that? Because this is a linear function, and it's a linear function because the highest exponent on your X value here is a 1. If the exponent was a 2 here, then you would have a quadratic. It would make a parabola, a U-shaped graph. All right, but moving on from that. We have a function here, Y equals 3X plus 1, and then we're given Y equals 6. Well, I don't know why I just said that. We are given X equals 6. So if we're given X equals 6, then I know I can plug in 6 for one of my values. Now, since it says X equals, I'm going to plug this value in for the X value. Now, when I plug in, I have Y equals 3, and I'm going to substitute the X out. So just like in sports, when I want to put in a new player, right? So like let's say we're at a soccer game and we need to swap the goalies out. So can I put in a new goalie before I take out the other goalie? No. I have to take out the goalie that is in currently and then put in the new goalie. So I'm going to sub them out. Or if I'm playing football and I have a running back and I need to sub that player out, I would take out the running back that is in the game currently and then put in the new running back. This is kind of the same concept. I am getting rid of this X, I'm taking them out of the game, and I'm going to put somebody in new for the game. We're putting in this 6 here. Now, why do I have to use parentheses? Well, if you don't use parentheses, then it looks like you have 36. So 6 is what we're inputting into the function, so we're going to plug 6 in, and then we have plus 1 here. All right. So all I'm doing is just substituting the X value with a 6. Now once I'm there, I'm going to continue evaluating and simplifying this down. Well, what is 3 times 6? Well, 3 times 6 is going to give us 8 18, and then we have plus 1 on the end over there. Don't forget that there is a plus 1 in this function. And then I have 18 plus 1, which ultimately is 19. So that would be my final answer here, y equals 19. So what was our input? What did we put into the function? Well, what we put in was 6. We put in the value of 6. Our output, what we got out of the function, was 19. So our input was 6, our output was 19. So now we're going to go ahead and move into function notation and what that looks like. So this one asks to evaluate the following function for f of 6. We're given the function f of x equals 3x plus 1. Now we're going to go ahead and translate this into a language that we can understand a lot easier. So remember on the front page we talked about how y and f of x are the exact same thing. So just keep that in mind when we're doing this problem here. So first, we're asked to evaluate. Now, again, when you typically are seeing the word evaluate, you're either going to be plugging something in or you're going to have to look at something being plugged in or whatever, but you're asked to evaluate this. So think in your mind, okay, I'm going to have to substitute in a number here. You're going to evaluate the following function for f of 6. Now, f of 6 is very interesting because you guys haven't really seen something like this before. Normally, what we see is f of x. That's what we have seen. That's what we've seen on the last page. So we're like, okay, that's what we're familiar with. But now we're given f of 6. So like, what does that even mean? Well, what was there before the 6? What did 6 replace? 6 replaced this x that used to be here. So in place, it took its spot. So x was there, but now 6 is in its spot because it was f of x, but now it's f of 6. So what is this really telling me? This is really telling me in math language that they want me to take 6 and plug it in for x. How do I know that? Because the 6 is now replacing the x that used to be there. So this is basically what it's telling me without actually telling me that. And then I'm given this function f of x equals 3x plus 1. Well, from the front page, I already know that f of x is the same thing as y. So I'm going to go ahead and replace that with a y value. And I'm like, okay, this is a little bit easier to understand now. F of x and y are the same thing. So let's just cross off f of x and make a y there. But you're like, well, why didn't you cross this one off and put a y? Because they gave us a number here. They actually plugged in a number for x because they're telling us plug this in for x. So they want us to take 6 and plug it in for x. So we're going to do exactly that. So once we've translated those bits, we're going to go ahead and plug in 6 for this x value here. So we have y equals 3. And remember, when you're substituting, it is best to always use parentheses. That way we avoid our mistakes. So we have y equals 3 times 6 plus 1. Well, 3 times 6 is going to be 18, and we have plus 1, and we have y equals 19. So if you actually look, this is the exact same problem as the problem above, except it's asked in a different way. Above, we're just given normal y and x, and they just tell us to plug in a number for a letter, and that's what we're told to do. Here, we're actually using function notation to understand and interpret, okay, and I'm interpreting this as, okay, I need to plug in 6 for my x value, and then I also know that f of x is the same thing as y. So this problem isn't any different than the last problem, but it is asked in a way that you have to think about a little bit more. Now, our final answer here, I would prefer that you not write y equals 19, because if you think about it, there wasn't a y in your original problem, technically. So the way that I would prefer that you write your answer is f of 6 equals 19. Now, where did I get the f of 6 from? I got the f of 6 from the beginning of this problem. So what does this answer actually mean? This answer is telling me, the person that's reading your math homework every night, that you plugged in a 6 for x. You're plugging in a 6, but you get out a 19, and you're telling me that your y value is 19. So without telling me x equals 6 and y equals 19, you're just saying f of 6 equals 19. If I plug in a 6 into this function, I'll get out a 19. Now, will you always get out a 19? No. If I plug in a 4, I'm going to get a different number. If I plug in -5, I'll get a different number. So in short, this just tells me what you plugged in and what you got out when you did that. All right, so we're going to go ahead and practice this a little bit more. So we're given 3 functions here, f of x, g of x, and h of x. And all these 3 functions are different, as you can see. They're all equal different things. So why did they use different letters, f of x, g of x, and h of x? Well, it's kind of the same thing as why we all have different names. We need to have an identity. We need to be able to tell each other apart. If I taught in a classroom where everyone was named Charlie, that would be very strange, and everyone would just be Charlie, and it would be very confusing, right? So on paper, we want to be like, okay, I have 3 different functions. I'm going to name them 3 different things. I have the f function, the g function, and the h function. So we have 3 different things here. 3 different functions, so we can be able to tell them apart. So I don't have to say, oh, that one over there. I could just say, oh, the g function, oh, the w function, oh, the k function. Now, given those equations, they want us to find three values. They want us to find f of 4, find h of -2, and find g of 6. Essentially, we're asked to do three separate problems here, so I'm going to go ahead and divide my workspace up into three separate parts. Now I'm going to go ahead and look at what I'm asked to find first. They want me to find f of 4. Well, if I'm trying to find f of 4, first I need to figure out what does f of 4 even mean. Well, remember, f of 4 used to be f of x. So if f of 4 was f of x, they're really telling me, hey, take the 4 and plug it in for all your x values, because the 4 just replaced the x. They're saying, hey, take out x, put in the 4. So that's what that's really telling me. All right, now I've got to figure out which function am I going to use up here. I'm given three options here. I'm given the f function, the g function, and the h function. Now out of these three functions, only one is the one to pick. Because they want me to find f of 4, then I'm going to be using the f of x function. So I'm going to go ahead and write that down here. F of x equals -2x plus 5. I don't want to use a g of x, and I don't want to use the h of x function. Those are not the two functions that I'm asked to use here or to evaluate from. So once I have that function written down, I'm going to go ahead and do some translating. I know that f of x is the same thing as y, so I'm going to go ahead and rewrite this equation as y equals -2x plus 5. I'm also given the f of 4 at the top, which essentially is telling me, hey, the x has been replaced by a 4, so replace all of your x's with 4s. So I'm going to look down at my function below, and I see y equals -2x plus 5, and anywhere I see an x, I'm going to plug in a 4. So I have y equals -2, and in the place of the x, I'm going to plug in a 4, and then I have plus 5. Well, from here, I'm like, okay, let's keep evaluating. So there's a couple options here. You can either type this in your calculator, or you can do this all in your head. I'll first do it in, not all in my head, but on paper. I'll go ahead and first do it all on paper, and then show you how you can actually type it in the calculator. So we have y equals -2 times 4 plus 5, so let's go ahead and evaluate. This is going to be -8. -2 times 4, and then we have that positive 5 on the end there. And then -8 plus 5 is going to give us -3. So our answer is y equals -3. Now, how can you do this all in the calculator? Well, once you have, and you can see that you know what you're plugging in, and you see, oh, all of my math is happening on one side, like y is kind of dead weight over here, y is not really doing anything. All of my math is on one side here, so I can type all of that into my calculator and evaluate for that. Now, you would do this in your main calculator screen, so I'm using a calculator app here, or if you have a graphing calculator, that works a lot better because it's something to get used to, but you're going to type in exactly what you saw for the problem. So we saw -2, parentheses 4, parentheses plus 5. So I'm going to type in exactly that into the main screen of my calculator. -2, parentheses 4, oops, messed up there, delete, 4, close parentheses, plus 5, was it plus 5? It is plus 5. Okay, and then hit enter, and I get -3. So again, your calculator will do that work for you if you don't feel like doing it, but it's always good to know your mental math skills. So how do I write my answer though? We're not going to write our answer as y equals -3. We're going to write our answer as f of 4 equals -3. And why are we writing it this way? Because I'm telling the reader, hey, I plugged in a 4 for x, and I got out -3 for y. All right, so let's move on to the second value that we're evaluating for, h of -2. Now here again, the -2 is replacing x's spot. So they're telling us plug in -2 for your x value. So they're saying x is equal to -2 here. Now we got to figure out which function we're going to use here. So out of the three functions that we're given, the f, the g, and the h function, because this is asking us to find h of -2, then I'm going to be using the h of x function. So I'm going to go ahead and write down the h of x function for this problem. And I know exactly where I'm going to go from here. So I know that h of x is technically the same thing as y. So the first step I'm going to do is get rid of that and make it a little bit easier on my brain to understand what is happening here. H of x is the same thing as y, so let's just get rid of it. All right, now we're going to go, okay, what do I do from here? Well, they're telling us at the beginning that x is equal to -2. So we're going to find all of the x's in this problem and replace them with -2's. It is very important that you use parentheses anytime you're plugging something in. Even though you think you don't need it, it is always better and safer to do that. So we're going to go ahead and plug that in. We have y equals 3. Now this x, again, we're replacing that x and we're replacing it with a -2. Now here's where people start to mess up. This exponent of a 2 was already there and it was a part of your problem from the very beginning. You're not plugging in that exponent, so that exponent should stay outside the parentheses. Whatever is inside the parentheses is what you plugged in, that you made that choice to plug it in. That exponent was already there, so you need to leave it outside the parentheses. Plus 2, and then we run into another x. Well, for every x that we see, we're going to have to plug in that number, and in this case, we're going to plug in -2. Again, you can do this all in your head, or you can, not all in your head, but all on paper, by hand, or you can use a calculator. So I'll do it by hand first and then show you in the calculator. So we have y equals, now when we're doing this part here, you need to actually calculate negative 2 squared first. So negative 2 squared in this case is going to be positive 4. And then this section over here, 2 times negative 2 is negative 4. From here we have 3 times 4, which is 12. And then we have 12 minus 4, which is 8. So I got the answer 8. Now, if you type this in the calculator, you can just go back to where, after you already knew what you're going to plug in, you're going to type all of this into the main screen of your calculator. So I have, clear, 3 parentheses, negative 2, close parentheses, and then we square that. I already lost my train of thought, and where I'm supposed to go from here, plus 2 parentheses, negative 2. Hit enter, and I get positive 8. So again, you'll see that I'm also getting an 8 here. Now, that's correct because we did it twice and they were both the right answer. But we were at our answer here. What number did we value, or what number did we plug in? We plugged in negative 2. So we're going to see that our answer is h of negative 2 is equal to 8. So when I plug in negative 2 into this function, I get out a positive 8. Again, whatever you plug in will change whatever your answer is. So if you plug in positive 7, you're going to get out a different number. All right, and lastly, we're evaluating for g of 6. So out of the 3 functions here, the function that we're going to want to use is that g of x function. So I'm going to go ahead and write that one down. Now, why am I using this function? Because it wants us to evaluate for g of 6. So I'm looking for the g function to evaluate that from. Now, again, g of 6 really says, hey, take the 6 and replace all of the x's with it, because the x has been replaced with the 6. So in math language, they're telling us x equals 6. And now down here, we're given this function, but again, we already know that g of x is the same thing as y, so let's get rid of that. And then actually do our inputting here. So we're going to input x equals 6 into our function. Now again, always use parentheses when you're substituting in, so y equals 2/3, and we're going to have in parentheses positive 6 minus 1. Now if you can do this by hand, then that's great. 2/3 times 6 is 4, and then minus 1, and 4 minus 1 is going to be positive 3. I can type that in the calculator, so I'm going to type in 2/3. So remember, to type in a fraction, you do alpha, y equals, enter. So 2/3 times 6 in parentheses minus 1, and I get positive 3. So I do get that as my final answer. So we're going to write g of 6 equals 3. So when I plug in a 6 into this g function, I get out a positive 3. Moving on to the last page of this section of the notes, which is over evaluating functions. We have evaluate the function with the domain -306 to find the range. All right, so that's a big mouthful of what the heck did I just read, right? So let's first dissect this piece by piece. They want us to evaluate, which means they're probably going to be plugging something in. Evaluate the function with the domain -306. Let's talk about what these squiggly curly things look like, right? These are called curly braces, or also curly brackets. In math, there are a couple things that you see that kind of look like this. If I ever give you something that looks like this right here, that is an ordered pair. That is a point. Parentheses are reserved for points. So we only use parentheses when we're talking about points. These two guys right here are not parentheses. So this is not one giant point. Curly braces or curly brackets are used for when we're listing things. So they're listing out numbers for us. They're listing out -3, 0, and 6. So they're listing out 3 separate numbers for us. But more specifically, they're listing us numbers in the domain. So it says evaluate the function with the domain -306. Now, what variable is associated with domain? Your x variable. So they're technically giving us our x values. How many x values do they give us? Oh my gosh, my iPad is a little frozen right now. 1 second. Okay, how many x values did they give us? They're giving us 3 x values. And in the end, they want us to find the range. Well, they want us to find the range. Well, what variable is associated with range? Your y variable. So they're giving you x, and they want you to find y. So typically, you're going to be given one, and you're asked to find the other. So in this case, we're given 3 x values. They want us to find the 3 y values. So they also give us this function down here, k of x equals 7 minus 2x squared. Now, this is the point where we start to translate and kind of get rid of things that we don't really want around. So in this case, k of x, get rid of that. What is that the same thing as? That's the same thing as y equals 7 minus 2x squared. Get rid of that to make a y there. And that helps, right? Because they want us to find y, so that'll help our brains kind of see where y is. Now, they're giving us 3 x values, so I'm going to go ahead and split this problem into 3 separate spaces so that I can evaluate for those 3 separate x values. So the first thing I like to do is, well, what are the values that they give me? They give me the first x value, which is -3. So we have x equals -3. So I'm going to put that on that left side. The second x value they give me is x equals 0. And the third x value they give me is x equals 6. Now, I'm going to use that function, y equals 7 minus 2x squared in baby blue right there. I'm going to use that for each of these values. So first, I'm going to evaluate for x equals -3. So I'm going to go ahead and copy down the function that I have above. And then I'm going to evaluate. Well, x equals -3. So where am I going to plug in -3 into this function? I'm going to plug it in for your x value because x equals -3. So we have y equals 7 minus 2. In parentheses, we have -3. Now remember, that exponent was there at the beginning of the problem. You're not plugging that in. That's not something new, so you need to keep it out of the parentheses. The parentheses are reserved for the stuff that's new that you're plugging in. Now again, from here, you can type this all into the calculator or do it by hand. Not to save us some time, I'm going to go ahead and just type it in the calculator. So 7 minus 2, parentheses, -3 squared is going to be -11. So we have y equals -11. Is this my final answer for this entire problem? No. I need to find all 3 y values. So this is the first y value, so I'm going to go ahead and circle it to let myself know, hey, this is important information, come back to this later. But we're going to go ahead and move on to the second x value, which is x equals 0. Now again, I'm going to go ahead and write down the equation that I was given at the very beginning, y equals 7 minus 2x squared. And then I'm going to go ahead and plug in for the value that I'm given. So I'm given x equals 0. So I'm going to plug in 0 for my x value. So I have y equals 7 minus 2, and in parentheses, 0, and squared. Now when I plug this into the calculator, 7 minus 2 parentheses 0 squared, I get 7. So I'm going to go ahead and write a 7 there. And then I have, as my final answer, not yet, right? Because that's our second value. And then we're going to move on to the last x value. And again, I'm going to use that same function I was given at the beginning. I'm going to copy that down. Now I know this time for x, I'm going to plug in positive 6. So I have y equals 7 minus 2, and in parentheses, I have positive 6. And then I'm going to square this. And again, you can type all of this into the calculator and you can get the value there. But I'm going to go ahead and do this one by hand just so that we're refreshed on what we're supposed to do here. 7 minus 2. Again, you want to get rid of that exponent in the parentheses first. So you're going to do positive 6 squared, which is 36. And then from here we have 7 minus 72, because -2 times 36 is -72. And this should give us -65. But because I get paranoid, I need to type it in. So 7 minus 72 is... Oops, enter. Is it working? Oh, it's frozen. -65, yes. Okay, so that's our third y value. So we found all the y values. Did they ask us to find the y values? Yes, they did. So always be sure that you're actually finding what they want you to find. So they wanted us to find the range, which is finding your y values. We found all 3 y values based on the 3 x values. So how do we write our answer here? Well, you're going to write your answer in the same way that they gave it to you, in curly braces. So I'm going to go ahead and open up some curly braces. My first y value here is -11. My second y value here is 7. And my third y value here is -65. And then I close my curly braces because that's the end of my list. And this would be my final answer. Now, does the order of your numbers matter? It does not technically. You can also list it from least to greatest. Some people like to do that. So -65, -11, 7. STAR tests will commonly list things from least to greatest in answer choices. So just know that the order doesn't technically really matter as long as all the numbers that you listed are there. I'm not going to be super picky about it, but just a FYI, you know. All right, moving on to the next problem. Evaluate the function with the range -1, 5, 23 to find the domain. And then you're given the function h of x equals 5 minus 3x. Now, you're asked to evaluate again, so we're probably going to be plugging something in. But now this time we're evaluating the function, and we're given the range of -1, 5, and 23. Now, what variable is always associated with range? Y. So they're actually giving us the y values this time. They're giving us the range. They're giving us 3 separate y values. And what are they wanting us to find? They want us to find the domain. Find x. So this is basically unit 1. Find x. Solve for that x variable. So because they're giving us 3 y values, again, I'm going to go ahead and split up my space into 3 separate areas to make my work. Now, because they're giving us y values, it is very important that you do not plug in for x here. It is the most common mistake because people want to plug in for x because that's what we've been doing for the last 30 minutes. But they're giving us the range. The first y value they give us is -1, so I'll go ahead and write that down there. The second y value they give us is +5, and the third one is 23. So I'm going to go ahead and write y equals y equals y equals to remind myself to plug it in for y. Now with this function here, I'm going to go ahead and translate this. I know that h of x is the same thing as y, so we have y equals 5 minus 3x. So this is the function I want to use to evaluate, so I'll go ahead and write that down for our first y value here. So I have y equals -1, which is what I want to evaluate for, and then I have y equals 5 minus 3x. I'm going to substitute in the number now. Y equals -1, so I'm going to plug in -1 for my y value because it says y equals. Do not plug it in for x. They did not give you x. In fact, they want you to find x. If they're wanting you to find x, you don't have it. All right, so from here we want to solve for x, which is basically unit 1 from this point, so get x by itself. First step here would be to subtract 5 from both sides. Anything you do to one side, you got to do to the other. 5 minus 5 would make 0 on the right side. On the left side, -1 minus 5 is -6, and you're still left over with a -3x. Lastly, to get x by itself, we will divide both sides by -3 because -3 is attached by multiplication. So we have x equals -6 divided by -3 is +2. Now again, this is part of our answer. So we found our first x value. Now we got to keep finding the other two. So we have y equals 5 minus 3x is our original equation here, our original function. And then we're going to plug in our second y value, which is 5. So 5 is going to go into y's place. And we're going to solve for x again. So first step in solving for x, get rid of the 5 first. So we're going to subtract 5 from both sides. 5 minus 5 is 0. Subtract 5 from the other side. 5 minus 5 is 0. So at this point, a lot of people assume, oh, your answer is no solution. No, it's not. You have not accomplished the goal of getting x by itself. So do not claim that you have no solution until you have tried to at least do it and your answer actually shows you no solution. Is x by itself yet? It is not. X is still there, and x has a -3 attached to it by multiplication. So you still need to get it by itself, so you can divide it off. -3 divided by -3, that cancels because it's 1, so you technically have 1x here, but we don't write the 1. And then you also have to divide the other side by -3 because anything you do to 1, you got to do to the other side. 0 divided by -3 is 0. So your second x value is 0 here. Our third y value here that we're given is 23, so I'm going to go ahead and write down the equation that we were given initially. Y equals 5 minus 3x. And our last y value is 23, so we're going to plug that in for the y value there. 23 equals 5 minus 3x. First step to get x by itself is to subtract 5 from both sides. 5 minus 5 is 0. 23 minus 5 is 18. And we have 18 equals -3x. We're going to divide both sides by -3 to get x by itself. So -3 divided by -3 is 1x, or just x. Divide the other side by -3. 18 divided by -3 is -6. All right. So now that we are here, we have our 3x values. So how do we write our final answer? We're going to write it in those curly braces because they gave us the range. They gave us the y values in a list. So we're going to list back the x values. So I usually just go in order because out of habit. So we have +2, 0, and then -6 as our 3x values that we got. All right, and we're moving into the last two problems of this section. Given g of x equals 4x minus 2, find the input when g of x is 18. So let's go ahead and translate all this. Given g of x equals 4x minus 2, so we know that g of x is the same thing as y. So we're going to go ahead and rewrite this as y equals 4x minus 2. So we're given a function here, y equals 4x minus 2. They want us to find the input. Find, which means they want us to search for, find the answer for the input. What variable is considered your input? It is x. So they want us to find x in this problem. Okay? When g of x is 18. Now, g of x, again, we already talked about this. What is g of x really the same thing as? G of x is the same thing as y. Y equals 18. So let's just go ahead and talk about the difference. If I'm given f of 5 and then f of x equals 5, these two things mean two completely different things here. So if I'm given f of 5, they're taking 5 and substituting the x in that place. So they got rid of the x and they're saying, hey, plug in 5 for x. Whereas on this right-hand side, they're saying take y and plug in 5 for y. So one is x equals 5, the left side. This is telling you to plug it in for x. And then the right side saying plug it in for y. So those mean two completely different things, and it's something that you're going to have to get used to. It's a little different. But in this case, it's saying g of x equals 18. G of x as a whole is y. So y equals 18. So now that I have all my information, they're saying here's a function in the beginning. find x, and then we're going to give you the y value. So they're telling us to find x, we're going to give you y. They always give us one, they want us to find the other. So we're going to plug in this, I don't know what happened. They're giving us this value of 18 for y, and we're going to plug it in for this y value over here. So 18 equals 4x minus 2. And we're going to solve for x. Why are we solving for x? Because they want us to find the input, find x. So the first step in order to solve for x here is we're going to add 2 to both sides. Negative 2 and positive 2 make 0. And then we have to add 2 to the other side as well, which gives us 20 equals 4x. Our last step to get x by itself is to divide both sides by 4, because 4 is attached by multiplication. 4 divided by 4 is 1x, and then 20 divided by 4 is 5. So did we answer the question? What did they want us to find? They wanted us to find the input, find x, which we did. So our answer here is x equals 5. All right. And moving on to the last one. Sorry, I had to move that because I need more room. Given p of t equals t squared plus 3, find the input when p of t equals 39. Now, here it says, given p of t equals t squared plus 3. They didn't use any x's in this problem. Normally, we see like g of x, h of x, k of x, p of x even. But they're giving us p of t. Now, as always, p of t or p of x or g of x or anything in the front there is going to be the same thing as y. That does not change. Now, in this problem, they didn't use x's because it's normally f of x, g of x, k of x. They're using p of t, which means that instead of using x's, they're using t's. And you got to keep it the same way. So you got to keep it a t. We're not going to change it into an x. They want to use t's, so we're going to use t's. The t's are going to act like the x's in this case. The y can stay y, but the t's got to stay t instead of x. They want us to find the input. Find the input, or in other words, find x, right? Because input is x, but problem. There are no x's in this problem, right? So what are we actually finding for? If there are no x's, what did they use instead of x's? They used t's instead of x's. So they're really saying find t. Find the input, which in this case is going to be t. Also, if you're ever confused on what the input is, whatever letter is inside these parentheses right here, that's your input. All right, so they want us to find t. And then they're giving us p of t equals 39. Well, again, p of t is the same thing as y. So I'm going to go ahead and get rid of that p of t and put a y in its place. So they're giving us y equals 39. So I'm going to take that 39 and plug it in for y over here. All right, so we have 39 equals t squared plus 3. Now your goal here is to get t by itself, except there's one problem. We're encountering for the very first time an exponent in our actual equation. So what does that mean? What does that tell us? Well, if you remember back from Unit 1, we talked about how solving equations, we use PEMDAS backwards. Now, why do we use PEMDAS backwards? Because it helps us take the steps to solve equations in the correct order. PEMDAS backwards means I'm always going to add or subtract anything I can add or subtract before I ever step foot into the world of multiplying and dividing something away. So the goal is always add or subtract if there's something to add or subtract, and then you multiply or divide. So like in this one, for example, I got rid of the 2 before I got rid of this 4 over here. Because the 2 is being subtracted, the 4 is being multiplied. So I'm going to take care of the subtraction first before I take care of the multiplication. So in PEMDAS, I always work with addition or subtraction first before multiplication or division. But we really haven't stepped foot into the E, which stands for exponent. If we're doing PEMDAS backwards, your exponent should be taken care of last, after you've added and subtracted and after you've multiplied and divided. So you're going to solve this like you normally would to get a variable by itself, get rid of everything around it. Now, you got to get rid of that exponent and you got to get rid of the 3. Now, because the 3 is attached by addition, we're going to get rid of that first because you always add or subtract before you multiply or divide before exponents. So we're going to go ahead and subtract 3 from both sides. That gives us 39 minus 3, which is 36, equals t squared. So our next step here is, how do I get rid of that exponent? Well, the opposite of squaring something, the opposite of that, we would need to do in order to get rid of it, right? Because why do I subtract 3 to get rid of positive 3? Because they're opposites. We always do the opposite to get rid of things in algebra or in math in general. Right here I have 20 equals 4x. How did I get rid of the 4? Well, because the 4 was attached by multiplication, I divided by 4. I did the opposite. So I need to do the opposite of squaring something so that I can get rid of it. And the opposite of squaring something is square rooting something. So I'm going to square root the square. When I square root the square, they should cancel because they're opposites of each other. So that means that I would be left with just a t. The exponent is gone. So square rooting a square makes it go away. But anything I do to one side, I have to do to the other side. So I also have to square root the other side of my equation, square rooting 36. Well, what is the square root of 36? Some of you might already know the answer, but if you don't, your calculator is super helpful for this. So If you look above my cursor here, there is a blue square root symbol right here. It's kind of hard for me to point to because you can't actually see my finger, but there's a blue square root symbol right above this x squared button. So the blue square root symbol is only accessible if I press the blue button right here, the second blue button. So I'm going to hit the second blue button and then x squared, and I get a square root symbol, and I'm going to type in 36 and I get 6. So t equals 6. However, you technically have two answers here. So let's talk about what square rooting something means, right? Because why is the square root of 36 6? Well, the square root of 36 is 6 because 6 times 6 is 36. Because the same number times itself gives me 36, so the square root of 36 is going to be 6 here. Well, then what's the square root of 81? Square root of 81 is 9. Why is it that? Because 9 times 9 is 81. What's the square root of 100? The square root of 100 is 10, because 10 times 10 is 100. What's the square root of 9? 3, because 3 times 3 is 9. So all of these have something in common. The number times itself makes the original number. But how did we end up with 6? Well, because we square rooted 36 and we got 6, because 6 times 6 is 36. But there's technically another answer, because doesn't negative 6 times negative 6 also equal 36? And doesn't negative 9 times negative 9 also equal 81? And negative 10 times negative 10 equal 100? And negative 3 times negative 3 equal 9? A negative times a negative is a positive. So don't we technically have two answers here? Because if square root of 36 is 6, because 6 times 6 is 36, then negative 6 is also the answer, because negative 6 times negative 6 is also 36. So you really have two answers here, 6 and negative 6. So anytime you're square rooting a number, you're going to have two separate answers. And the reason why is because we have something called a quadratic. So I'm going to go ahead and type this into Desmos to kind of show you. Now in Desmos, I'm going to use x's instead of t's. So I'll go ahead and show you what that looks like. So we are given the equation y equals x squared plus 3. Now again, we're given t squared technically, but I'm getting rid of that t and putting in x for the sake of graphing. And then they said at the very end, y equals 39. You're like, where the heck did you get that information from? At the very end of our problem here, y equals 39. So I type in y equals 39 there. Now I'm going to go ahead and zoom out so you guys can kind of see what's happening. And I'm going to tap on the 2 points that it intersects at. It intersects at 2 different points, negative 639 and 639. Notice how both of your y values are 39 because it wanted y to equal 39. But two different x values allow that to happen, negative 6 and positive 6. So that's why you have two separate answers, because when I draw a line through this, it crosses through twice. So I'm going to have two separate answers in that case. So this one is a very important problem to kind of remember, because when you square root, you're going to have two answers. And the way that you can remember that is this little baby 2 should remind you that you're going to have two answers when you're done. But that is evaluating functions and sequences. The honors section, which composite functions, is in a different section. So if you are in honors, then make sure you click on the video for that. But other than that, the sequences video will be